Hello friends, welcome to Crackgate CSE, and in this series of database today we'll be discussing categories of index. So under categories of index we'll be understanding dense index for ordered field and unordered field, and we'll be discussing what is sparse index. So the categories and types are two different things, do not get confused with it. I'll be creating a separate videos on type of index too. So before starting this particular video, if you have not subscribed the channel, subscribe the channel, and in the end of the video, once you found this particular video useful, don't forget to like the video and don't forget to share your feedback or the suggestions in the comment box, right? So let's start with the categories. So the index is divided into two categories. One is dense index, another one is sparse index. As the name is clearly suggesting that in the dense index we'll be having more number of index or more number of pointers, right? Whereas in sparse index we'll be having comparatively less number of pointers, right? So what is the definition for index? For dense index we'll be having more index entries. Why we'll be having more index entries? Because for each record of database file there must be an entry in index file. But that means if I'm having n number of records in database file, then there has to be n entries in the index file. That means the size of the both of the file, whether it is a database file or the index file, be same in case of dense index. What does it mean? That means number of index file entries will be equal to number of records of database file. So here you can see that I am having these many records and the exact same records are in the index file too. So this is database file, this is index file, and the size of the both of the tables or both of the database files are same. So this is the database file and index file, so it is same. Now let's see how it will be representing using the help of pointers. So we'll be having a pointer for each entries or each record of database file. That means here I am having two, so I am having a respective pointer in the index value like this, right? Similarly for 4 I am having a pointer, for 6, for 8, and so on. So I am having pointer for all the entries of the database file. Let me complete it, right? So how many pointers you are having, how many index entries you are having, equals to the number of records of database file. So here you can see that the number of pointers are more, so that's why it is known as dense. And another thing you might have noticed that this is a ordered file. Why it is a ordered file? Because the keys are sorted in a specific order. It can be ascending order or it can also be descending order, but generally we talk about the increasing order, that means ascending order. So this is ordered in ascending order. And the index file, as I already told you that indexing is possible only if we are having the ordered field. That means the keys in the index file has to be ordered in every case. That means the keys in an index file will be always ordered. So this is for the ordered file. What if the database is having unordered file? So here you can see that this is unordered because we are having 2, 4, 6, 14, 18, later we are having 8 and so on. That means this is not sorted in any order. So this is unordered. Unordered database file. Whereas you can see that the index file, the keys are always ordered, right? Now here also we will be having same number of index pointer entries, like 2 will be representing here, 4 will be here, 6 will be here, and 8 will be here, you can see, right? Similarly 10 will be here, what is 12 is here, 16 is here, and 18 is here, 22, 20, this is 22, right? This is 20, so 20 is here. So here also you can see that the number of index entries or the number of pointers is dense, but the only difference is this is under ordered file and this is under unordered file. So this is always having more number of entries. But if you go to the second category of index, there is sparse index. So sparse index will be having comparatively less number of index entries. So for a set of database records, there exists an entry in index. That means here it says that for a set of database record, and here it was saying that for each record. So you can easily get the difference. Here we are referring a set as a block. That means for each block we will be having a pointer or we will be having a key pointer entry in the index file. So this is a database file and this is a index file. And the sparse index is always ordered, right? This is not possible for unordered, right? So this will be always over ordered key. What does it mean? This means that the keys of the database files needs to be sorted. They cannot be unsorted. If it is sorted, then only the sparse index is possible, otherwise it is not possible. So the number of index file entries will be less than number of records of database file, because here for each specific block we are having one pointer. For 6 there is one pointer, for next block there is one pointer, similarly for other block. Here you can see that the number of keys are 6, but for these 6 values we are having just 3 pointers. That means the number of index file entries is less than the number of records of database file. Now the number of blocks of the database file, that means whatever the number of blocks we are having in database file, that many number of index entries will be there, because for each block we are having one entry, right? So for these 3 I'm having these 3 entries and so on. So I hope you got an idea how the things are working under the category of index. In the next video we will be discussing an important question on indexing which can be asked in your competitive exam, whether it is GATE, NET, NEET or any other PSU exam. So if you found this particular video useful, like this video, share it with the friends, and don't forget to share your views, feedback and suggestions with me on my comment, right? So if you want to connect with me over the Facebook group or page, the links are given in the description. You can always connect with me. So thank you very much for watching. Keep supporting, keep learning. Have a great day.